Hello, we faithfully deliver value and interpret great books from around the world. Hi, this is Sally Talking Books. Today I'm interpreting the book called The Autopsy Report with the subtitle A Mortician's Notes. So, what comes to mind when you hear mortician? Feel free to leave your thoughts in the comments. Many might picture scenes of applying makeup to the deceased and coffining and cremating bodies in funeral homes, but the mortician described in this book is quite different from what we typically imagine.
In the BBC TV series Sherlock, Holmes and Watson appear at the Bath Pathology Museum, which holds over 5,000 pathology specimens.
And the author of this book, Carla Valentine, is the technical curator of this museum. Before becoming the curator, Carla worked in a mortuary for 8 years, performing about 5,000 autopsies as an anatomical pathology technician. In the UK, doctors who specialize in disease and death pathology are called pathologists. They perform autopsies to determine causes of death, similar to forensic doctors in China. Technicians like the author, anatomical pathology technicians, mainly assist pathologists in physical tasks like opening bodies, removing organs, and collecting tissue samples. Similar to dissection workers in China, since she's a technician in a mortuary, the author prefers to call herself a mortician to avoid lengthy explanations to non-experts. Autopsies are seen as quite mysterious by many. Ordinary people's views on autopsies mostly come from literature and films. But for artistic reasons, autopsies in such works are often exaggerated or modified. So, what does a real autopsy look like? The autopsy report we're discussing today gives a detailed account of postmortem changes and the full autopsy process. But it also encourages deeper thinking about life and death. Just a heads up! Next, we'll unavoidably cover a lot about dissecting bodies, which might make you uncomfortable. So please brace yourself and listen at your discretion. Autopsies are divided into external examination and dissection. Now, I'll interpret the book's main content from these two perspectives. First, how the external examination is conducted. Second, how the dissection examination is conducted. First, let's talk about how the external examination is conducted. Before we begin, we need to clarify a question. Do all bodies require an autopsy? Not necessarily. In the UK, unless the deceased saw a doctor within 2 weeks and the doctor confirmed the cause of death is clear, an autopsy may be skipped. Otherwise, it's almost always required.
Yeah.
So, in China, autopsies are generally only performed when public security authorities or family suspect unnatural death and the cause is uncertain. When autopsy personnel arrived at the scene or opened the body bag, the external examination begins. So, what kinds of bodies do they encounter? You might not know, but bodies start decomposing right after death. Some are discovered long after, so autopsy personnel face all sorts of decomposed corpses. In cases like explosions, jumping from heights, train suicides, or dismemberment, the bodies might be mutilated or incomplete. So, how do they perform the external examination on these bodies? Let's start with decomposed bodies. In TV dramas, we see investigators applying menthol under their noses or stuffing tissues in nostrils to block the persistent, strong, foul smell. The source of this stench is the odor emitted by decomposing bodies. However, the body's smell might hide clues that reveal the truth about the death. For example, if the stench has an alcoholic odor, the person might have died from excessive drinking. Therefore, professional autopsy personnel don't try to block the smell. They just get used to it. The author believes decomposition has 5 stages: fresh corpse, bloat, active decay, advanced decay, and dry remains. When autopsy personnel open a body bag at work, it's like unboxing a mystery. Any stage could appear. Now, I'll explain each stage. The first stage is fresh corpse, characterized by rigor mortis, livor mortis, and autolysis. First, rigor mortis means body stiffness. Within 1 to 2 hours after death, muscles relax from nerve loss. Within 4 hours, relaxed muscles contract from elasticity loss, starting rigor mortis. Rigor mortis first forms in small muscle groups, like eyelids, fingers, and erector pili muscles. This stiffness can make scalp hair roots stand up, creating an illusion of hair growth. 4 to 6 hours post-death, it spreads to large muscles, stiffening the body and fixing joints. Oh, if you try to forcefully change the limb position now, it could easily cause bone fractures. Once rigor mortis spreads throughout the body, livor mortis becomes noticeable. Livor mortis forms when blood circulation stops and blood settles under gravity, creating purplish-red marks on the skin. They tend to concentrate on the lower, unpressed parts of the body. For example, if someone dies lying face up, their back and buttocks, where pressed, turn pale. Unpressed areas show large patches of livor mortis, which usually sets firmly about 12 hours after death. If the body was moved before that, you'll see signs of livor mortis shifting. This helps forensic investigators piece together the sequence of events. The third feature of a fresh corpse is self-digestion. Within 36 to 48 hours after death, the body softens as rigor proteins break down, leading to decay. One cause is self-digestion, or autolysis.
Actually, it starts just 4 minutes after death. Substances in cells, stomach, and pancreas that digest tissues break free and attack. Ah!
This process creates liquid byproducts, causing blisters filled with red or brown fluid on the skin. After about a week, they swell and burst, and skin sloughs off.
Autopsy personnel can even peel skin off hands like removing gloves.
The second stage of decomposition is body bloating. In this stage, with autolysis and cell breakdown, microbes invade tissues, changing color and causing swelling. At this point, hemoglobin in blood turns into sulfhemoglobin under microbial action. Sulfine globin emits a sulfur smell and makes skin turn greenish to purple, eventually turning black, and since the gut has the most microbes, this color change starts there. Green spots usually appear first on the lower right abdomen, called wet green spots. Microbial activity produces gas trapped in cells, making popping sounds when the body is moved. If gas escapes through the digestive tract, it results in corpse farting or burping. More commonly, natural orifices, like the digestive and respiratory tracts, get blocked by decay, causing bodies to swell 2 to 3 times their original size from trapped gases. Like an inflated balloon, internal pressure makes eyes and tongue bulge out. This is called a bloated corpse. The bloated corpse. When examining bloated corpses, autopsy staff must brace for unbearable stench, especially outdoors. Avoid downwind positions. Internal gases mix putrescine, cadaverine, sulfur, cyanide, methane, and scatol, combining rotten eggs, swamp gas, and feces into an intolerable cocktail. If unautopsied, trapped gases make skin rupture around 2 weeks post-death from pressure buildup. By then, organs lose all form, becoming mushy sludge. The third stage is active decay. Here, body mass plummets from fluid drainage and scavengers like maggots. Within 24 hours of death, flies lay eggs in wounds or orifices, hatching into maggots. Hundreds of maggots devour the corpse, growing into rice-sized larvae that wriggle across the body. The fourth stage, advanced decay, has blurred boundaries, but maggots typically drop off when full, ready to pupate. The fifth stage is dry remains, mostly bones, cartilage, and hardened, leathery skin. Like ancient Egyptian mummies, bodies can self-mummify in extremely hot, dry environments. Decomposition speed and patterns vary under different temperature and humidity conditions. And so how do we pinpoint time of death accurately across conditions? Forensics uses body farms, research sites where bodies decompose in varied natural settings to collect data. Bodies mainly come from unclaimed remains or donations. This way, during investigations, forensic experts can use the data to help police catch suspects. Before body farms existed, pigs were often used for such experiments, but later studies comparing human and pig decomposition data found significant differences. Using incorrect data as trial evidence could lead to wrongful outcomes, which drove the creation of body farms. From the moment of death, decomposition is inevitable. Rot affects appearance and creates foul odors, making viewings before burial difficult. The need for viewings and farewells spurred modern embalming techniques.
Unlike ancient Egyptian mummification, modern embalming uses refrigeration short-term, plus chemical preservatives replacing bodily fluids to slow decay.
If an autopsy is needed, chemical preservation usually happens afterward. Embalming fluid mixes formaldehyde, methanol, and solvents into a peach-pink solution. Tubes connect to neck arteries and veins. Fluid pumps in through arteries while blood pushes out through veins, with massage ensuring even distribution. The peach-pink tint gives skin a natural tone. Besides arterial injection, cavities get filled with fluid too. After embalming, technicians seal nostrils, mouth, anus, and other openings with sutures or cotton to prevent leakage. Embalming presents a peaceful appearance, allowing dignified farewells that comfort grieving loved ones. In China, embalming isn't common. In the UK, it's optional and only done when families request it. Beyond decomposing bodies, autopsy staff also encounter mutilated remains. For these, technicians reassemble body parts like jigsaw puzzles to check completeness. Before autopsying explosion victims, X-rays scan for embedded shrapnel, bomb parts, or other hazards. Beyond examining the corpse's state, during external examination, we also check external items on the body, like clothing, jewelry, wallets, as well as physical features such as body type, skin color, tattoos, and wounds. These external details might provide key clues for determining death circumstances, so every detail must be carefully documented. For example, if the deceased is extremely thin and weak, they might have died from malnutrition or wasting diseases like malignant tumors. If the body is cherry red all over, it could indicate death from carbon monoxide poisoning. If the skin is unusually pale, it might suggest death from massive hemorrhage. If there are leaves or branches on the body, it might mean death occurred outdoors, and so on. Additionally, during external examination, we might remove implants like pacemakers or defibrillators from the body. Batteries in pacemakers and defibrillators can explode during cremation, so in principle, they should be removed if cremation is chosen. In the UK, removed pacemakers are donated to charities for reuse to help patients in poor countries. But in China, funeral home rules vary. Many places don't enforce pacemaker removal. After external examination, we move to dissection. This is what the second part will cover. In this section, I'll focus on explaining the methods and steps of dissection examination.
That's because the book's author is an anatomical pathology technician, mainly assisting pathologists with physical tasks like opening bodies and removing organs, not typically involved in cause of death analysis.
So the book rarely mentions related content. Actually, not all body examinations require dissection. Only when external examination alone can't provide a clear conclusion, risking cause of death determination, is further dissection needed. Dissection can be divided into systemic and regional dissection. Systemic involves opening 3 cavities: cranial, thoracic, and abdominal, while regional complements it, targeting potentially injured areas like the perineum, spinal cord, lower back, buttocks, or limbs. Next, I'll focus on systemic dissection. Its steps include pre-dissection prep, skin incision, opening the 3 cavities, suturing and repair, each with standardized procedures. Next, I'll explain them step by step. First is pre-dissection preparation, covering both tools and personal protection. First, prepare tools: scalpels with fresh blades, rib shears, skull saws, absorbent paper towels, various scissors and forceps, suturing needles threaded with thick white thread, and plenty of sample containers. I'll cover these tools' specific features and usage in detail later. Gather all tools before starting to avoid fumbling around covered in blood and fluids during the procedure. Besides tools, personal protection is crucial too. Bodily fluids might splash onto clothing during dissection. With decomposed bodies, maggots can crawl everywhere. So in principle, wear non-woven dissection gowns, waterproof aprons, face shields, masks, caps, triple gloves, shoe covers, etc. for protection. But in practice, this gear is stiflingly hot and cumbersome, and masks hinder using smell to assess the body. That's why many autopsy staff don't suit up fully. The author mentions wearing green surgical gowns and plastic aprons over protective gear, plus hairnets, plastic face shields, and sleeves to prevent fluids running down. Gown sleeves absorb to elbows. Fabric gloves between latex layers prevent cuts from scalpels, needles, or bone fragments. Once prepped, systemic dissection begins. Step 2. Making the skin incision. There are standard incision methods: straight line, Y-shaped, T-shaped, curved, inverted Y, etc. Different countries choose methods based on cases.
China typically uses straight line, from mid-chin straight down to above the perineum, cutting skin and subcutaneous tissue.
It veers left around the navel. Quick and convenient, but damages neck structures. When neck injury is suspected, it's replaced by the Y-shaped method, most common in Europe and America. The Y-shaped cut starts behind both ears, meeting at the collarbone dip, forming a neck V-shape, before continuing like straight line. The Y-shaped incision, besides avoiding neck injuries, can be concealed by clothing after suturing, making it more aesthetically pleasing compared to the straight line incision. When cutting the skin of a corpse, the tissue reaction differs from that during life. In TV dramas, we might hear lines like, "The wound shows vital reactions, proving it occurred before death." Here, vital reactions refer to a series of responses after injury when the body is still alive, such as tissue contraction, bleeding, swelling, and scabbing at the incision edge when cutting living skin, which are absent in a corpse. In other words, injuries occurring before death show vital reactions, while those after death do not. After cutting the skin, we begin the systemic dissection examination. Step by step, opening the 3 cavities, including the thoracic, abdominal, and cranial cavities. First, open the thoraco-abdominal cavity. Autopsy personnel should separate the skin, muscles, and other tissues from the ribs as a whole by gently pinching one side of the incision and lifting it while using a scalpel to detach the tissue from the ribs. Thus, the muscles between the ribs are exposed, and moving downward leads to the abdominal cavity. Upon entering the abdominal cavity, the first thing seen is a large, flat, yellow substance. This is the greater omentum, composed mainly of peritoneum and fat. It drapes over the abdominal organs like a yellow apron, providing some support and protection. At this point, the skin of the thorax and abdomen has been cut open, and the rib surfaces are fully exposed, allowing us to proceed with opening the thoracic cavity. So, 12 pairs of ribs are neatly distributed between the sternum and spine, with the first 10 pairs connected to the sternum via costal cartilage. To open the thoracic cavity, use rib shears to cut the costal cartilage on both sides of the sternum, then remove the sternum to expose the cavity. Once both thoracic and abdominal cavities are fully open, it's time to remove the organs. Organ removal is also methodical. It can be done en bloc or separately. Among these, organ removal en bloc is more commonly used, also known as the block method. That is, removing all organs as a single intact unit, typically starting from the tongue and thyroid in the neck, pulling down through the thoracic heart and lungs into the abdomen, and then extracting them together with the abdominal and pelvic organs. The advantage of this method is that it preserves the anatomical connections between organs and continuous vessels, like blood vessels, making it easier to observe the relationships between pathologies in different organs. Besides en bloc removal, organs can be removed separately as needed. For instance, by cutting the esophagus, trachea, and aorta above and below the heart and lungs to isolate and extract the cardiopulmonary region for focused examination. And 4. Examining organs plays a vital role in determining cause of death. For example, there was a case where a sudden death was initially suspected to be from myocardial infarction. But during autopsy, no infarction lesion was found on the myocardium. Instead, there was a needle puncture mark. Subsequent lung dissection revealed extensive pulmonary infarction. The final determination: air injected into the heart entered the pulmonary artery during contraction, causing fatal pulmonary embolism.
Well, this shows that without autopsy, criminals might escape justice.
After torso dissection, we move to the head and open the cranial cavity. TV dramas often show autopsied corpses with dramatic forehead scars, but that's inaccurate. The standard head incision runs from behind one ear over the skull to behind the other ear, never across the forehead. After lifting the scalp, technicians fold it forward and backward while using scalpels to separate tissue from the skull, fully exposing the bone. They simultaneously examine and record head conditions like bleeding or skull fractures. Preserving hair hides the incision under hair for better aesthetics, but compromises scalp injury examination. That's why hair is sometimes shaved before incision. Next, craniotomy typically uses an electric oscillating saw with circular or fan-shaped blades, nothing like the bulky chainsaws in movies. The saw cuts hard bone but spares soft tissue, preventing operator injury. Craniotomy generates significant debris. A vacuum tube can be attached to section debris. After sawing, a T-shaped chisel and hammer gently separate skull from dura mater. Once separated, the skull cap lifts easily to reveal the brain. Pale pink, soft-textured, and intricately structured. When removing it, support the brain with one hand while using a scalpel in the other to sever nerves and spinal cord connections through various openings, then cut the meninges and tentorium, separating cerebrum and cerebellum to extract brain tissue intact. Fatal head injuries are common, but sometimes deceptive. For instance, a man walking by a river fell in and died, seemingly accident or suicide, but autopsy revealed a subdural hematoma in his skull.
Turns out he'd been hit by a car the day before death.
After falling, he quickly got up, found no injuries, and went home, unaware that impact caused intracranial bleeding. Worsening hemorrhage made him lose consciousness and fall into the river. Thus, autopsy findings can drastically alter case trajectories. System of autopsy examination. Step 4 is suturing and restoration to honor the deceased with dignity and comfort grieving loved ones. First, organ replacement. Post-autopsy, thoracoabdominal organs are often placed in viscera bags before being returned to the body cavity. The extracted brain, preserved in formalin for sampling and too delicate, is rarely reinserted. Instead, cotton molded into brain shape fills the cavity to stabilize the skull cap. Plus, cotton absorbs fluids from numerous craniofacial orifices, preventing leakage through ears or nostrils. Next, suturing. Forceps hold C-shaped or S-shaped curved needles threaded with thick white thread, leaving baseball stitch-like marks. Finally, grooming. Washing the body post-suturing. For severely damaged bodies, skin-toned bandages wrap suture lines for a cleaner, more peaceful appearance. Beyond standard autopsies exists perinatal autopsy, specialized examinations of fetuses and newborns. In the UK, 15 to 25% of pregnancies end in miscarriage, with over 80% occurring in the first trimester. When seeking consent from expectant parents, many agree to autopsy.
But in China, perinatal autopsies are less common. They clarify fetal death causes, helping couples take preventive measures in future pregnancies.
Perinatal autopsy procedures resemble adults, but differ in key aspects. First, small gestational fetuses have soft skulls with fontanelles, so craniotomy typically uses scissors instead of saws. Fetal brains lack adult convolutions, resembling soft pink milk jellies.
During restoration, fragile fetal skin often can't be sutured. Instead, specialized adhesive seals incisions after alignment.
That covers the book's main content. Death remains taboo in many cultures. Even among Sahara's Tuareg tribes, fear of death runs so deep that when someone dies, they relocate campsites and never speak the deceased's name again. But Norwegian expressionist Edvard Munch said, "From my rotting body flowers shall grow. I am in them, and that is eternity." Through scavengers, plants, and microbes, life cycles continue, death nourishing new life. Thus, death isn't terrifying. It represents rebirth. Similarly, autopsies as truth-seeking science shouldn't be demonized. Death may bring grief, but truth shouldn't be buried with it. Let evidence speak, exonerating the innocent, upholding justice, giving voice to the dead, while protecting the living. That's autopsy's purpose. After hearing this book, what new thoughts do you have about the autopsy profession? Feel free to share in the comments. All right, that concludes our interpretation of the autopsy report. Study notes are below the audio. See you next time.